Hello, welcome to Learn Noir in an Afternoon or Get Your Money Back. I'm José Pedro Souza. I'm a DevRel engineer at Aztec Labs, and today we're going to be talking about Noir, the ZK DSL developed by Aztec Labs. We're going to be talking a little bit about ZK, what is ZK, what can you do with ZK. We'll also talk a little bit about Noir. Why are we doing this? Why is Noir needed? What can you do with Noir that you can't do with other ZK DSLs? Then we're gonna present our project, our little project for today. And finally, we're gonna hack it and just start hacking stuff. So we know that zero knowledge proofs are really powerful. You can do stuff that you can't do with any other tech, basically. But usually with great power come univariate polynomial commitments, and this is kind of the problem because if you don't get the math behind ZK, usually you're just left in the dark. And basically the purpose of Noir is to make this go away and just abstract all the complexities from the mathematical part of the ZK space. So we need this usable universal ZK domain specific language. And yeah, we like Rust. Rust is cool. So yeah, we just went and copied the syntax from Rust. And so if you try to find the difference between the two programs, they're usually you're gonna have a very bad time. And so this is just an example. If you try to spot the difference between these two snippets, yeah, you're not gonna find them. One of them is Rust, the other one is Noir, and as you can see, there are little differences. In this case, there are zero differences. We want you to write code instead of writing circuits. So if you've used other ZK DSLs in the past, maybe you've written like circuits on a piece of paper and then connect the wires, and that's basically how you write a circuit. We believe that the best paradigm is the one that we are used to, which is just writing code, like just writing actual programs, like you'd write Solidity or JavaScript or Rust. And this also allows you, like for very very experienced developers, to just use Noir to abstract their own stuff. So maybe they just want a very easy way to use ECDSA signature verification, for example. So maybe they don't want to write their own stuff and just use Noir, like Noir modules or external libraries. Well, this is still easy for beginners to start using ZK. So today we're gonna be building a little project. I'm gonna show you next what it is, and we're gonna divide this in like 3 chapters. The first one is literally about Noir, and especially Nargo and Noirup. How can you simply get started with a new Noir project? I'm gonna be talking about the syntax of Noir. I'm going to be writing tests. Actually, they're built in with Nargo, but I'm going to show you how to make them fail and stuff. And finally, what we all care about, which is proofs, actually generating the proofs and verify them. We're going to also be integrating some libraries, namely the standard library that you'll find many of the built-ins in Noir, and other libraries like external libraries built by the community or libraries that you want to build yourself. And finally, we're going to be looking at the browser usage. Yeah, it's a bit of a beta, but you can still do it, and you can use it in your dApp, and I'm going to show you how. We're going to be leaving behind the verification of proofs on chain. I'm going to show you basically how to generate the contract, but from then on, I'm assuming that you know how to deploy a contract with Foundry or Hardhat, or Truffle is not around anymore, unfortunately. So that's it. I'm just rambling here, so we should get started finally. Yeah, you should check out the workshop resources as well. Especially the workshop resources. You're gonna have a repo there with the stuff that we're gonna be using for today. So I highly recommend you to scan this QR code. Um, Also, the Noir docs. This is basically the documentation that the Noir team has been putting on, and it should give you most of the answers you're looking for. And finally, my Linktree. It's not Linktree. I think it's a Limbo. Yeah, it's a Limbo thing. You can check out there all my like Twitter handle and Telegram and stuff. So you can talk with me and ask questions if you want to. And so that's it. Let's start hacking basically. So I'm gonna pull up my VS Code editor here. Uh, as you can see, this is already in the workshop resources I just mentioned to you. And if you check out the README, you're gonna find this NoirUp tool. So NoirUp is if you use to CLI tools like Rust app or Foundry app, which is actually here. It's basically a CLI tool that will install Nargo. And if you use to Rust, you also know Cargo, which is kind of an npm thing that will install like a package. It's a version manager, a package manager, and also runner and run scripts and stuff. So that's basically what Nargo does. So to install NoirUp, you just go and install it. Like you can just copy this. You can trust me, bro, and just copy this thing. It will install NoirUp for you. This can take a little bit longer for you, so just pause the video and wait for it to complete. And yeah, it says that you should just run source and just source the bash file, or just start a new terminal session, and then finally you should have NoirUp around, and you can check what does it do, and you're gonna get like the options for it. And so it's pretty powerful. You can install like specific versions and branches, PRs, commits, and stuff. In this case, even though I think the latest version of Nargo is 0.10, let's just go ahead and install like a specific version for that. And so I'm gonna install like version 0.11. So you just go and install that, and it will download and install for you. I guess that's the one I had already because it was really fast. And then you can just go and run Nargo version. And finally, you should have here your version. Another thing that you could probably find useful is the VS Code plugin. So if you use VS Code, you can just go here on extensions and basically say just run Noir, write Noir, and you're gonna get here Noir language support. So yeah, it's a very alpha version, but it's really cool, and it can run like it has some code lines that can be useful for you to run. You also get like syntax highlighting, which is always cool. So with Nargo, you can basically do all kinds of really cool stuff, like running your code and installing package and starting a new project. And that's basically what you're going to be doing. So let's just go run Nargo help to see what can we do with Nargo. In this case, we're going to just use the new command and just call it like Noir project. And yeah, it will generate a new project here. And you have two files basically. Nargo.toml is basically the source of your project. You can define whether it's a library or a binary. So yeah, also define dependencies and workspaces here. For now, we're just gonna leave it as it is. Don't change it. Also, Noir generates a main.noir file for you, which basically has a very basic circuit you can test and run and do whatever you want. And so yeah, let's just go over it and see how can you run your own. So let's start with the fn syntax, which means function basically, and you need to have a main function. That's part of it because you're running the main file. If you have other files, yeah, you can have like modules and stuff. You can look at it in the documentation. And you also need to define like the name of your inputs, and also their type. and you also need to define whether they are public or private. So we think that privacy is normal, so you only need to define the stuff that you want to make public. And so the biggest difference is that obviously if you have something that is public, you gotta assume that the verifier has that in their possession. While for private, it's stuff that it's only on your machine that you don't want to reveal, but you still want to prove some calculations on it. In this case, we're going to use the field type, which is basically an element of a finite field. And so you can treat it pretty much as a kind of a big integer and make all kinds of really cool operations, arithmetic operations on that. And that's basically what field is for practical purposes. If you want to define an array, for example, then you just do it just like in Rust. You define the type, and then you find how many elements does your array have. One thing that you should notice is that you need to know this at compile time. There is no way of just passing like a slice. This doesn't work with basically any of the ZK languages I've ever worked with. So yeah, this is not new. Another thing you can use is like some really cool return values. So you can have like public field and make this return a field. And so you can have like, for example, let z and say x plus y, and then just assert like x is different from y, and then just turn z. And yeah, this will return you a field. And some people ask me like, why should I have like public outputs for return values? Why do they have to be public? And the reason is like basically the way it's treating the return value, it actually as an output, as an input. So this would be just the same as like returning something like this, public field, and then just constraining at the end. So as you probably noticed, I already used some arithmetic on it. You can sum them up. You can subtract them. You can do all kinds of really cool stuff. And if you want to know exactly what you can't do with fields, you can actually just check the Noir docs. Do that for you. Just here are the Noir docs. You can go here like on the language concepts and see all the things you can do, like logical operations, and just send them, and even like bit shift and stuff, as long as they are integers. And yeah, so this list will hopefully give you some examples as well. You can skim through if you're interested. Also the shorthand operators, which are really useful at times. You can also use loops and control flow stuff like ifs and else and stuff. So basically the way you write them, it's just like in Rust, you'd say like for I in some kind of range, you say, oh, thanks GitHub Copilot. It already knew some example for you. Yeah, you can run like your for loop just like this. And yeah, you can also do it like a conditional. So you can say if x is not 1, or if it is 1, then y is something like this. So yeah, you can run if else's just like you do with Rust. There's also the assert keyword that you probably saw at the beginning, and that you're gonna say assert x is different from y. So this is something that you don't get in Rust. So yeah, if you try to run this, it'll complain that it doesn't know what assert is. And this is basically what you want your program to do. Basically, I want this proof to generate some constraint and say that this proof will only be valid if x is different from y, and I don't want to reveal what x is. And so that's what assert keyword does. Another really cool thing they can do is structs. So yeah, you can define like a new struct and say struct person, for example, and just have some stuff like not strings. We have strings, but yeah, they are. Yeah, let's not use them, not today. So you can define structs and just pass them, like you can pass that here X could be a person, for example, with X age, etc. So for our project, let's imagine that you are the owner of a fight club. So you're gonna say that each fighter is a person, and that person has an age, which is gonna be a field, for example. And you wanna check that only people with a certain above a certain age are allowed into your fight club. You also want to check, for example, that they know like the password uh, to enter your fight club. There's a secret password that you don't want the bouncer to know what it is. And so let's just go through it and say, yeah, there's a person. This is going to be a fighter that has a certain age, and then you're going to have, like, for example, a password. And obviously a password is a private input, so let's not reveal it. But the hash of the password, that's definitely something that can be known, because it's very difficult to figure it out. And so let's just get like password hash. Password hash is going to be a public input, and let's say it's going to be also going to be a field. And so in your program, all you want to do, it's basically two things. One is just like check if age is bigger than minimum age. And the second thing is like you want to check if the password hash is equal to the hash of the password. So yeah, GitHub Copilot already know how to do it. Yeah, let's just see how can you use this hash thing. Another thing that can be useful in this case, for example, is global. So you can go and say global and say global minimum age is going to be a field, and let's say it's 18 because I'm in Europe. Yeah, I don't know if it would be different in any other country. And let's just get ourselves some space here. And so yeah, let's just go, and you can literally write 2 lines of code and see fighter age of the fighter needs to be higher than the minimum age. And this takes care of your first assertion. And I can just go and test it already. I can go and say let P is a person with age, for example, age 19. And so I can say that 19 is here. I'm gonna just pass whatever random values for the other two. Yeah, and see this should pass. I'm gonna go and run an Argo test. Okay, oh sorry, I need to cd into that. Our project, and then go and Nargo test. Oh wait, sorry, I forgot. Is P. Yeah, it will complain that fields cannot be compared. Yeah, that's something that's true. You can compare fields. So let's just cast them as U8s. Let's say actually make this already a U8, so it's easier. And yeah, this will hopefully pass then. Another really cool thing you can do with Nargo, at least the latest versions, is to write syntax that should fail, and this can be useful, very useful, I guess. And just go and call test that should fail, and then you can run and test that should fail. Let's just go. I hope GitHub. Okay, yeah, that's, he knows already. He knows. So yeah, you can go and run Argo test, and this should pass because this test should fail. Regarding the password, so we have our password and know that the verifier knows what the password hash is. So that means in our circuit we need to hash our password and just check if the hash that everyone knows is equal to the hash that we are calculating in our own private input. So basically, we are saying the hash of the input that only I know is equal to the hash that everyone knows, because it's like in a smart contract, or just everyone knows for some other reason. And how can we do that? We basically do that with the standard library. So the way you import it, it's very easy, because you can just import it like this. It's just a standard library. So just dependency standard library. You don't even need to add anything to nargo.toml. It will work out of the box. Let's just go on the browser to see basically what do you have there, and you have a wall chapter for Noir standard library, and this you have like really cool things like recursive proofs and Merkle trees and stuff, and also all the cryptographic primitives that we currently support. As for the hash methods, you have many hashes that we have implemented already. Some of them are what we call black box function, and this basically means that this is just provided by the backend. So if you use different backends, you may have they may not be implemented. If you're looking for a hash method to use, I would recommend it to use some zk friendly hash. That would be, for example, Pedersen or Poseidon. Let's just go on Poseidon because I like it. And yeah, the way you import it, it's just like this. I'm actually gonna copy this so you can see and go over on my VS Code window as well, and just paste it here so I don't forget how to use it. And so the way you import it is you have std, so you can actually go here and import it here, and so you can have more granularity on what exactly are you trying to import, and say let's just leave it as this is, and so this way you can have your program be a little bit less verbose and just have the module you're importing specifically. And so in this case, we want to check, like you want to yeah, it's not really that, as GitHub says. So you just want to check that your password hash is equal to the hash that you're trying to do. In this case, you just go and run the password. And the reason GitHub thought I was trying to pass an array is because, yeah, password should be an array. So he was kind of right. So yeah, in this case, as I told you, you need to know the size at compile time. So yeah, I'm hashing two values, so I'm passing the hash 2, so it would be 3 or 4 or 5 or whatever, depending on what exactly are you trying to hash. It says that's not being used, which is a lie. Okay, now it's okay. And yeah, that's it. Now for testing, basically, it will complain that yeah, it expects a field 2, which is kind of true. And so here's what the utils folder can be useful, because you do have like an implementation of Poseidon that you can actually run on your machine and see how does a hash look like. So you just go here, you just change your inputs and then run this like with TS Node, for example, and you're gonna get an output. So in this case, I think I already have two values here that can be used like for Poseidon. So if you have like 1, 2, for example, the hash of that should be this. So yeah, in this case, I'm gonna just paste and say, yeah, the password is 1, 2, which is a very weird password, but let's forget about it, and just say the password hash is this one. And while we're here, let's just go and do the same for the test that should fail. So I'm gonna just change this 8 for a B, and this hopefully should pass like both tests. Let's go and try. Yeah, as you see, they all pass. This one passes because the value is correct. This one passes because the value is incorrect. If you've seen the utils folder, you also have another one called Keccak, which is basically the same thing but using Keccak, which is a hash function that is widely used in Ethereum, but it's not very zk friendly. So one thing that you want to do basically is to prove stuff, and that's all fine to run tests, but they are just tests. You actually want to prove and verification stuff. So the way you do it is just run argo check, and you have this prover and verifier files, and yeah, this is basically where you put your values and to be proven. So in this case, like we know what they are already, so I'm gonna just go and put like my password here, just here, and my password hash in quotes, inside quotes here, and the age of my fighter is going to be 19. So you want proof on this, and because this is Noir, it's as easy as just running Nargo proof. You're gonna see here like the proof. It has the name of the project, and yeah, it's very difficult to understand. But as you can see, it's kind of succinct, which is what we want. In the end, it's snark, right? It's supposed to be succinct. If you want to verify that, you just do the same thing. You just go Nargo verify, and you're gonna verify the default proof that's gonna be in this directory with the name of the project. At this point, you're probably asking, how can I do that in a smart contract? And as always, it's pretty easy. You just go and run Argo code-gen verifier, and it can take a little bit, but it will generate a smart contract for you. It was fast actually this time. So you have a smart contract here, which was written by very, very smart people. And yeah, it's gonna be a little bit difficult to understand all of this, but yeah, this is a smart contract you can deploy. The relevant function here is probably the verify function, and this is basically what does it expect to be passed on. At this point, you may want to explore a little bit more about the standard library, and you'll probably notice that it doesn't do everything you want, and that's okay. We expect that, and so there's a very easy way to just import other libraries. One of my favorite libraries is the ECRecover library, and this is by one of our community members called Colin, and Colin just put this library to basically recover an address from a signature. How can you use that? So let's go back to VS Code and just go on the nargo.toml. And here you have dependencies here. And actually there's here, yeah, just an example of how can you use ECRecover, which is like this. You go hey, ECRecover, you check the tag, and then if you want to import it, it's very easy. You go here and you just import it. Just use dep ECRecover, and there you have it. So as promised, I'll show you how to use this in the browser. So the way you can do that, we're not gonna use Nargo anymore, I believe. So let's just close this and just leave the circuit here. And basically, the way you do it is with 3 packages. So as I've explained before, there is Noir, and that's basically the language that you're writing, and that compiles into ASTER, which is the intermediate representation. And then we have 2 more packages, which is the ACVM that will translate that into a constraint system, and then finally your actual backend. And so the way you use it on the browser, it's just importing these 3 packages separately. So here in our project folder, you have the browser package, browser folder, and this is a basic React page. If you see here, like my component, I'm gonna input some numbers, X and Y. I want to check if that X and Y are different, kind of the other circuit that we know already. And then once the user clicks calculate proof, it will calculate the proof. And so, yeah, it will generate the witness and generate the proof. So the witness is like this ACVM part, and then from there with the witness you can generate your proof. So you have here the class Noir, and you are initializing as Noir, new Noir. And so yeah, let's get started. I'm not gonna write the whole thing, but there's a sheets file here. We can just go and copy line by line and just check and see what exactly does it do. We're gonna import our actual backend, which is Peroxyberg. Then finally we're gonna have also the init ACVM. This is needed only for the browser. That you need to init the ACVM. It's gonna be doing some WASM stuff in the background. And then finally the execution of the circuit and the compressed witness if you need to compress it, and we're going to do that, we're going to need that. You've probably noticed that there isn't any JSON file in our project, and that's because I just forgot to compile the circuit. And yeah, basically that's what we're gonna do. So we are in that folder already, so I'm just gonna go and run argo compile, and it will compile my circuit into the target folder. Then we are finally, like the big stuff, we are initializing Beretsenberg with 4 threads. So you can actually make this 6 or 8 or whatever. Yeah, just basically there's multi-thread support in Beretsenberg, and that's why it's actually so fast. We're also getting like the circuit size because we need to allocate some memory for our WASM stuff. So this is basically what it's doing. And finally, we are just storing the ACU composer, which is very handy interface to generate your proofs. As for the proof generation, I'm just gonna go back to my cheats file and just copy this just last 2 things. And yeah, while we're here, also copy the destroy method. And let's just go over them. Yeah, this is actually the easiest part. So if you have the witness already, you just call AC create proof from your initialized API. So if you remember, this API comes from the Beretsenberg, and so you've done a bunch of things to Beretsenberg to make it ready. So then it's just easy to go and call AC create proof, and you need to pass your AC composer and the buffer uncompressed, and yeah, you need to decompress your witness because it comes out of a CVM decompressed. And this false, you can just ignore it. It's meant to be used for recursive proofs. So we are actually also abstracting this away from you. And finally, you should have your proof here. Yeah, this should output your proof. As for the verify proof, it's kind of the same thing. And then yeah, you have like the verify proof, actual verify proof with the ACU composer and the proof and that flag that you can ignore regarding recursive proofs. And this is how we do you would do that in the browser, or basically also in Node.js. So I'm going to show you in Raster. We have some examples. One of them is the next hard hat, which is basically our project, but it's ready to use. So you can see like the utils also integrates Ether, so it already verifies on-chain your proof as well. And yeah, that's it. There's a circuit. Circuit is again very easy circuit. You can see it. It's just really basic. So yeah, it's, as you see, this is initializing the Noir like that init function. Then I'm passing just like 2 different values. And yeah, you see, this is really fast. That you'll calculated your witness, your proof, verified it, and then verified on chain. And this is it for Noir in an afternoon. I hope this was useful. Just let us know if you have any questions, if you want to do something more difficult and you're having trouble. Just reach out. There's the Noir Discord you should join. And also, yeah, you can just get in touch with us on Telegram or Twitter or by any other means. Thank you.